Thank you. Yeah, so I've taught for almost 27 years in Taiwan, and so I'm very senior, probably senior than all of the faculty here. And okay, so let me see. Oh, I forgot to say this. Okay. Yeah, and let me give you a little bit introduction or overview of my research area. And because when I study in Arizona, and we are trying to develop some kind of intelligence systems. And one of the area at that time would be to support radiology applications. When physician radiologists, they diagnose with the X-ray, CT, MRI, they need a lot of support from using the information systems. So my first research in Arizona will be an optimization problem. Okay, so at that time, the network speed is very slow and was very slow, and the storage was very limited. And in order to store all of the images, we need to distribute all of the images over different nodes. So when radiologists they need some images for a particular patient, the image need to be retrieved from the remote site. So one of the optimization problem would be, given we estimate the behavior of the radiologist from different nodes, how can we allocate all of the images over different? So that would be the linear programming problem. So we need to allocate and also including the duplications consideration. So we need to minimize the retrieval time, while we also need to minimize the storage usage. Okay, so actually that would be my first research when I was a master student in Arizona. And then I remember after all the mathematical modeling, the time to retrieve one image, okay, the optimal time that we calculate will be 6 seconds. So when a radiologist they enter the request, whether from the local side or the remote side, the average time will be 6 seconds. So we actually was very proud of the mathematical results. So we present the result and also present the mathematical models to the physicians. Okay. And some of the physicians, they were not satisfied with the 6-second results. They said their anticipation was 2 seconds. When they enter the button to request one image, they want to see the image within 2 seconds. Okay, so in order to cut the retrieval time, okay, from 6 seconds to 2 seconds, we need some other mechanism. Okay, so that was back to 1990s, okay, when I was the second, third year master students. So one of the solution would be, we need to predict the retrieval behavior of the radiologist. So before you enter the button, we prefetch the images. Okay, so that was the project that we collaborate with Toshiba medical imaging department, okay, back to like 24 years ago. So that was the first project I get into the machine learning. Okay, so because we need to predict the behavior of the radiologist. Okay, so actually I spent almost 6 months within the radiology department trying to understand their behavior. Why, okay, given the patients, 25 female patient, okay, and with the, for example, the heart attack disease, and the radiology probably need to retrieve the 2 months before, okay, the images, prior images. So we need to understand all the behavior. So I actually spent 6 months in the radiology department, and observing, talking to the radiologist, and then we built a intelligence system. So with the support of image prefetching, we actually cut down the retrieval time from 6 seconds to 2 seconds. Okay, so that was the first project I get into the machine learning. So from then on, actually I spent almost all my career on machine learning. So in terms of the technical domain, okay, I'm doing the big data analytics, text mining, machine learning, deep learning, and all the things related to artificial intelligence. And I'm also the kind of person enjoying solving the application domain problems. So I spent actually I investigate some of the domains like social media analytics. Okay, so later on I will present one of the study about how we analyze the social media data and trying to predict videos popularity. Okay, and marketing intelligence, patent analysis and mining. And we actually trying to analyze patents using, for example, the bibliographic informations. Okay, like how many inventors of the patent. Okay, what are the patent category of the patent, and some other information. So when trying to tackle some of the research problem like is the patent valuable? Okay, is the patent worth maintaining? Okay, and at the company level, we trying to solve, for example, what are the technical development orientation? What are the technical direction of the company using their current patent? We're trying to predict what are the area that they will move into. Okay, and in terms of the health informatics, we actually collaborate with several departments in Taiwan, including National Taiwan University hospitals and Veteran Administration hospitals. And so, for example, we are one of the projects I remember, we actually trying to predict the length of hospital stay of burn patient. Okay, at the time when they admit, when they get checking into the emergency room, we need to know how many days they will stay in the hospital. Okay, and the reason for this prediction, for example, if we can have the effective prediction, the physician can do the better family counseling. They can tell the patient's family how the expected day that your husband or your wife will stay in the hospital. Okay, and patent analytics, starting from 2 years ago, I'm interested in human resource management. Okay, and so for example, one of the study we just finished, we are writing the manuscript right now, is given the resume. If you give me a resume of a person saying that from T1 to T2, he is working at company 1 with the position A, and from T2 to T3, this person working at company 2 and position is position B. Okay, and we will predict what will be the next company and the next position this particular person will move into. Okay, and the reason we want to do this prediction is really a good decision support for the company, saying that if I'm interview this person, I have the resume of the person, and this techniques or model can predict this person will next possible position and company will be CI and position J, and then you can estimate the likelihood the person will join your company. Okay, something like this. Okay, and another topics that I'm currently working on will be startup analytics. I'm very interested in startup companies, and also I'm supporting. I'm currently other consultant, technical consultant of one or two startup company. So the study, we already finished the paper and submit to research policy, and that study will be: can we predict whether the company, this new company, startup company, will succeed within 5 years? Okay, and the definition of the success would be IPO, initial public offering, M&A, being acquired by another company, or move into the later stage. Okay, and so that is the one of the study that related to startup analytics, and another study on startups analytics would be: we are building a model to predict the fundraising size of a company. You think about a startup company, they are in the round 2, they are moving into the round 3. Okay, they need to raise money, right? Okay, so how much money can they raise in the next round? Okay, if we can predict, then they will provide a good information to the owner of the startup. Okay, and they also can support the decisions or evaluations of the venture capital, how much money the company may raise. If the prediction is very low, probably you don't want to get into, right? So anyway, we are actually, so all of the studies I quickly mention is we are building models to predict or classify some of the events, some of the phenomena that we are interested in. Okay, so Professor Bay mentioned about I'm also doing a lot of journal editings, decision support systems, and Pacific Asia Journal of Association for Information Systems, Information and Management, and ACM translation on MIS, and also the healthcare informatics research. Okay, so welcome to submit your papers to all of any of the journals. Okay, all right. So let me give you a very quick overview about some of my social media research on social media and analytics, especially to support marketing intelligence. Okay, so one of the study published in Information and Management will be when trying to, I don't know whether, I think you probably, you know, preference measurement, right? Okay. And so we need to know the product features, how your preference on the product features will affect your preference on the product. Okay. And then the typical the traditional methods for preference measurement would be using the survey, okay, using the conjoint analysis, and to do the modeling. Okay, and in this particular study, what we trying to argue is probably we can think about an alternative way of getting the data, okay, from the social media. So specifically, we analyze the product reviews, okay? And then in each of the product reviews, the customer or the users may say, I don't like the size of the phone, but I think the photo quality is good, blah, 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 blah. And then I give the rating of this particular product, for example, 4 out of 5. Okay, so you can see the particular user doesn't like one feature, but he likes some other features, and he give the very good rating to the product. So we use this information. So it involved that this particular study involved, we need to develop some kind of sentiment analysis methods, trying to analyze all of the writings, the characters writings within the product review. And then we trying to aggregate, you say price, some other users may say cost, Okay, so you use different words to describe the same product features. So we need to have some integration, okay, over different usage of the terms. And then we build a model. Okay, so in that paper, we also extend the traditional preference measurement models, and we develop our own econometrics model, okay, for that one. So it was published in Information and Management. And the second one I will actually present later, so I just skip right now. The third one is brand personality. Okay. For marketing people or marketing executives, they try different marketing efforts trying to develop the brand personality, right? So Google, when you think about Google, you may think about, okay, innovation, right? And you may think about, okay, something fantastic, something like this. When you think about LV, the fashion brand, you think about luxury, you think about some other very sexy, something like that. Okay, so the one of the critical questions or research question is, how can we know the perception of the customer? Okay, and whether the perception of the customer about brand personality is comparable to the company's view. Okay, I'm trying to shape my brand in being innovation, but a lot of, if customers don't think in this way, and all of the investment on the brand personality building will be failed, right? So we're trying to actually analyze the customer voice and what are the customer voice, product reviews, and over the post on Twitter or X. So in this particular study, we actually retrieve or download or crawl a lot of tweets from Twitter, and then we build a deep learning model to learn how to learn a model and to explain why this brand personality is being sexy, is being So anyway, it's actually a prediction model. And the last one here is also a working paper, and is we are trying to currently a lot of brand company, they are not hiring or collaborate with celebrity because the price is too high. Okay, so they're trying to find some micro influencers. Okay, which means that on social media platform, their followers would be probably like less than 500,000, less than 20,000 followers. And so they are more cost effective to promote the brand, right? So right now you have a lot of micro influencers. Okay, so for example, I'm Nike company, Nike. Okay, which micro influence is better for me to promote my brand? Okay, so which investment I need to put down, right? So this would be the matching problem, right? I'm given a brand, Nike, I've given a brand, Coca-Cola, okay? And there are a lot of micro influencers, okay? Who are the best choices to promote this? So this, again, we analyze different type of informations. For example, the brand, they also put a lot of posts, okay, in the form of text, in the form of video, in the form of some other like voice, something like that. And again, micro influencers, they also write, post their images, post their video, and write their comments, that write their posts on the social media, for example, the Instagram, okay. And then we're trying to analyze the text, images, video, okay, and then trying to build a matching model. Okay, so we will produce for a given brand, and then all the possible micro influence who should be ranked the first. Okay, so because we are analyzing different types of information, so this will be the multimodal deep learning model. Okay, all right. So there are 4 of the studies either have been published or we are still working on the writings of the papers and related to the social media analytics, and especially targeting to address the marketing intelligence problems. All right. So if you have any question, just stop me, okay? And I'm very happy to answer all of your questions, even though I may not know all of the answers to your question, okay? All right, so let's move to the specific studies, and this will be the popularity prediction model for advertising videos on social media platforms, okay? And as I mentioned earlier, social media has been a very good channel for companies to promote their products, to promote their brands, and also is an excellent platform for users to understand products, all right, to evaluate the quality of the product. All right, so right now the social media has changed the way people interact with brand. For example, consumer increasingly prefer to discover new products on social media platform. Over 70% of the people have positive experience with a business if they actually if they prefer one brand, 70% of the time they will recommend on social media, and your friend will see your post, so they may be influenced by you, right? And from the company side, social media marketing becomes one of the new channel for them to promote and engage with the. So one of the mechanism that they do is they constantly share their contents and launch advertising campaigns, videos on the social media, okay, so that they can increase customers' brand awareness. They can create positive brand associations, blah, 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 blah. So this is one of the video posted by Nike, okay? And this is another video by Nike, and I don't know whether you know the 2 persons, okay? The person on the video on the left-hand side is, that's okay. That's okay. Let me take the chance to. Do you watch NBA games? Right. Penny Hardaway retired like 10, 15 years ago. Yeah, he was also a legend, right? In Orlando Magic. So they create a video using the Penny Hardaway's hockey tape. Okay, trying to link Nike with the users of my age. So when I look at this, oh, Penny Hardaway. So I feel Nike is very close to me, right? You know who is the players on the right-hand side? Victor Wembanyama. Only you. He is the rookie of the NBA players playing for San Antonio Spurs. Okay. And he was like 220 and very long hand. Okay. And he was very, I mean, he was like 19, 20 years ago, 19, 20 years old. Okay. He will be a star in the next 10, 20 years. Okay. And anyway, so Nike created a video. Okay. And then about an interview with Wembanyama. Okay, so this is how they think about. Oh, probably Nike's audience will be young generation, like sports, right? And NBA is a very, very popular association or games. So they actually trying to build a relationship with the players, and at the same time, they're trying to build a relationship with the customers, users. Okay. So, and here, so like I already mentioned, a lot of brand companies, they are just like producing a lot of advertising videos and push on the social media, in the Instagram, in the Facebook, in other social media platforms. Okay, and so this become a very popular and prevailing strategies for brand companies. And so right now, the question would be, if you look at these two, 1 month ago, 90 posts and 40,000 people have viewed. And this 1 month ago, 60,000 people have viewed this, right? Okay, so this will be a very good result. Some of the Nike or some of the Adidas, Coca-Cola, they put a video on the social media. After 1 month, 1,000 people view. So that video actually doesn't create any good result to the company, right? So if we can, when the video was pushed on the social media, or when the video, before the video was placed on the social media, if we can predict how many people will view the video, okay, and actually you can do some of the selections, or you actually can change your promotion strategy to promote some of the videos. Anyway, so the reason we want to do this research is, if we can effectively, accurately focus the performance of a video, we can actually help the company to answer some of the questions like this. For example, how should a release advertising video being promoted so that we can increase the popularity, increase the number of views of the video? And so this will be the execution stage, right? The video has been pushed, has been released on the and some of the questions will be the planning stage, like what kind of contents I should produce, okay, so that the video will be popular on the social media, or there will be a lot of people watching this video. And whether a long or short video, or whether a video title contains specific keyword, will attract more attention from online users, okay? So if we can build a model to predict, the model will become a decision support system to answer some of the questions like this. So the underlying question, research question is, can we predict the popularities over time? Okay. All right. So like this, then I actually download the 2 days ago. Okay. This is Adidas. So if you look at this video, I don't know this person, but being put online, 2,000. It was good, right? 2,000 people have viewed this video. But this one, 2 days, 35,000 people have viewed. So if you consider the effectiveness of the video, the second one is not good, right? And this one has been 3 days, but only 900 people view this. So the predicting this number over time will be an important research question for companies who consider the social media marketing is a very good marketing channel. All right. All right. So prior study, there are different types of study using different approaches to address this prediction problem. The first approach would be if you give me some observations, okay. So if you accumulate, you know, the number of views on the first day, second day, third day, accumulate it, and then you help me predict the products, the number, okay? So using the observation in the observation period to predict the view counts, daily view counts, okay, of the prediction period. This actually is a very typical curve fitting problem, right? I trying to build a curve model, right, using this curve, and then extend this curve, so I can actually predict the products, right? The future, the daily view counts of the future days. Okay, and so this represent one of the approaches about the popularity prediction. So, but what is the limitation of this approach? The video has been released. You need to wait for a few days, accumulated the observations. Okay, the longer you accumulate, the better prediction result, because it's a curve fitting problem, right? So it only can support the critical question about executions. It cannot support the questions about training stages, because you have made the video has been put on the on the platform, and you wait for 7 days, you wait for 10 days, and then say, oh, sorry, the view count is not satisfactory, so we change the way that we promote this video. Okay, so probably can only support some of the decisions, right? Decision support, but not the training. Okay, so that's one of the reason, the limitations of this approach. And the second approach, there are some other existing popularity prediction methods. They employ the metadata of the advertising video to predict the popularity for some future day, like day 30 or day 15. Okay, so they only use the metadata of the video. They are not using the observations, daily observations. Okay, okay. So you give me the what are the video, the metadata, the title. Okay, the who are on the video. Okay, how long is the video, and what is the category of the video? So that's called the metadata. Okay, so you use only the metadata, and then you try to predict the results. Okay, and so with this approach, actually, they can support the planning decision, right? Because you don't need actually put the video on the social media website, okay, and wait for a few days. You can, before you put it on, you use the metadata and to predict. And if you discover that the prediction result is not so good, okay, then I may defer, or actually I cancel this the advertising video for not putting online, right? Okay, but this type of the current research taking this approach, they are not so sophisticated enough. Okay, they actually do not assume any type of diffusion process. They only just like using some of the attributes and then predict one of the result. But if we consider the viewing behavior or viewing phenomena of a video on social media platform is actually very similar to a new product launching process. Okay, so the cumulative view count is actually like the number of customers accumulate for a new product. You understand what I'm talking about, right? So if we take this view to address the popularity prediction problem, actually you will see we are trying to model the popularity prediction using the diffusion perspective. Okay, so a new product, why you buy a new product? There are two types of inference factors that you may influence your decision. The first one is called external inference, because the product is very good quality because the brand is very high profile brand, right? So and because the prices are so high. So all of this, because the product, video or product, they are very good quality, they are very attractive. So I purchase this product. So I watch this video, right? I was not influenced by any other factors. The second one we call internal influence, caused by social network. Okay, because my friend basically purchased this coat. I feel he's very handsome. Right, I want to be like him, so I purchased very similar or the same suit. Okay, then my friend Julie, right, he like that video. So we have very similar taste. Alright, so I watched the same video. That's called internal influence. So any consumer's decision is influenced by one or both factors, right? Internal and external factors. Okay. And so starting from, so this actually, the innovation diffusion model is a very well-known, I believe all of you, or most of you have heard of this base innovation diffusion model. So they model the diffusion process using the two types of the inference, alpha and beta. Okay, and then solving this problem, and then you can actually get these formula. And alpha means the external inference, the quality of the video, the characteristic of the product. And beta means the internal inference factor, right? In this particular market, for this particular new product, okay, probably the social network inference is high, so the beta is high. Okay, and there are two other factors considered in this innovation diffusion model. One is P, means the estimate the maximum number of the potential customers. And then A0 means the initial early adopter, how many people will adopt when there are no one adopt, right? So you just, okay. So that's called early adopter. So in this diffusion model, there are actually 4 parameters need to be estimated. Okay, alpha, beta, P, and A0. Okay. So all of the marketing research, if you look at the marketing science paper in like 60, 70, 80, or 1968, they're trying to build different models, different ways to estimate alpha, beta, A0, and P. And this is just an illustration how they affect the diffusion curve. If your alpha is high compared to others, the curve will actually go very steep. Okay, if your beta is high, okay, compared to the yellow one is very flat. Yeah, because no social network inference. So you need to touch every customer, and they consider, oh, this is a good product. So the diffusion speed will be slow. So it will become very flat. Okay. And so if we can have alpha, beta, and A0, then we know that the diffusion for the performance, sales performance of the new product. If we can estimate alpha, beta, P, and A0 for advertising video, then we can actually project the viewing curve, right? The number of people watch the video over time. Okay, so back to my research objective is we actually trying to take the diffusion model into consideration. We consider the popularity. Okay, the viewing behavior is a diffusion process. Okay, and then we only want to use the metadata. We don't want to do the curve fitting. Okay, so that we can support both planning decisions and execution decisions. We want to predict the curve as early as possible. And then, so we also want to predict over time, not only for day 30. We want to predict day 1, day 2, day 3, so that you can give a more detailed diffusion process or the performance over time, so that the marketing people, they can take this as an input to change their or to modify their marketing campaign. All right. So any questions so far? All right. So with this, okay. All right. So let me give you an illustration. So we formulate the popularity distribution as follows. You give me the metadata of the video, okay? And then we want to do this right. We want to do it on the curve, okay? And because the curve is formulated as the diffusion, so actually we want to predict these 4 parameters. So with these 4 parameters, we can actually produce this curve so that we know day 1, day 2, day 3, day 4, how many people may watch your video. Okay, so right now the problem is metadata. We predict 4 parameters. So that would be the formulation of the problem. Okay, all right. So let me give you a very quick result, but I think that will be too detailed. Let me just jump into the methods. Okay, but anyway, let me use this as to give you to share with you the research gap we want to address. So we actually we collect a lot of prior studies related to popularity prediction. Okay, on social media. And there are a lot of studies over here. So we actually trying to develop a framework to organize different kind of research. One of the classification would be non-diffusion or diffusion based. Do their study assume this is a diffusion model, or this is only a diffusion model? Okay. And then another would be what type of data they use. Okay, do you use the time series data, okay, to predict the future of the data, or do you use the metadata, or do you use metadata and time series data? Okay, so we actually classify the studies into 6 cells, and as you can see, most of study take this one, meaning that they also want to predict the popularity as early as possible. Okay. But they take the metadata as input, and they don't assume that there's underlying diffusion process. Okay, so they just do a model. You give me the number of seconds of the video, you give me this, and then a model just predict, 30 days later, there will be 2,000 people watching you. So there's no diffusion model. Okay. And this one, no diffusion underlying assumption, and they take the time series popularity and also metadata, and this only take the time series data to the curve fitting. And only this cell, we couldn't find any study. Okay, and they're using assuming that the popularity, the viewing behavior is a diffusion process, and taking only the metadata as input. Okay, so as far as we know, to the best of our knowledge, we probably one of the earliest studies working on this area. Okay, and for the video social media popularity prediction, and so let me just jump into this. All right. So the specific formulation would be, we need some of the training data. But for each of the training data, we don't want to about we only know the daily but our prediction test within the metadata, then you predict out of it. Okay. So we are there's the missing thing. So we actually consider the gap, and please take my student 1 to 2 months to think there's a mismatch, right? The data only give you the day 1, 100 people view, day 2, 200 people view. There's no alpha, beta, And then, so anyway, after a few months, few weeks, and we actually find just a twist, very simple twist. Actually, you can solve the problem. So we actually consider the whole design the whole method into 2 phases. Training data, okay, we collect a lot of training data, and then we know the metadata of the video. We know the daily view. We do the coding. So we can estimate, okay, for each of the advertising video, what would be the estimated alpha, beta, P0, P and Q. Okay, assuming that they follow the base distribution. Okay, so the curve fitting help us to transform the data in terms of the time series application into the diffusion model from the space. Okay, and with this, and then we actually do the diffusion model learning. So we, based on the estimated parameter value derived by the phase 1. Okay, and then we trying to learn probability prediction model based on their metadata, and then predict the parameter value, estimate parameter value. Okay, so let me give you a very simple illustration of the 2 phases. So this will be the training data, right? So we collect BTS, the collaboration between BTS and the LP. And so they put it on the I have a publish release. So sorry. Where do I collect the data? YouTube. Okay, sorry, YouTube. All right. So this, assuming this is a training data, so we already know we have data, okay, and then we already collect their daily view count. Okay, so we have a lot of training data. So the first phase will be we do the curve fitting, right? Assuming the functional form of the base model, and we're trying to estimate what are the base optimal alpha, beta, P, and A0 to explain this, that to model this project. And then, so we do the curve fitting for all of the training videos. So we get all of the, we have the 4 parameter values for all of them. And then the next stage, phase 2, is using their meta data. Okay, we build a deep learning model trying to make, right, to make the metadata to the estimated alpha beta 0. Okay, and during the prediction phase, okay, you just give me your metadata, and I will give you the alpha beta, P and A0. And then we can actually using those. Okay, so this will be the whole process. Any questions? All right, so let me use this slides. So what are the metadata that we consider in this study? For example, the video title, okay? What the words that you put in the video title may affect the intention of the user to click on the video. The second will be the video text, because a lot of people on YouTube, okay, you do the search. So I want to look at Coca-Cola. I like Wimbenyama, so I just type in Wimbenyama, right? And so I look at, oh, Nike Wimbenyama. Oh, so I click this one. So video text will be another important text, okay? Very important feature. Video category, the same thing. Video topic category, duration. A lot of times, if you have only very short period of time, you cannot watch the video for 10 minutes, right? You may only watch like 15 seconds, 20 seconds, or 1 minute. So the duration of the video actually may affect the intention of the user to click on your video, okay? And thumbnail, right? Some of the video, the thumbnail, the image, you actually have the intention to click, right? A lot of times I watch Netflix about frequently. And some of the movie, the thumbnail image, you don't have any feeling about that image, right? So you just don't want to click that way. So the image may be thumbnail image may be an important information to be considered in the model. And also the top channel, right? The very popular channel attract a lot of people to watch. Very unfamous brand, nobody wants to watch. Okay, so the channel information, including channel topic, channel subscriber count, channel video count. Okay, some of the brands they constantly push media so that users may expect if I go to their official website, I may see the new videos. Okay, and for some of the brands, they only release videos once a month. I don't want to go to that one because every time when I go there and there's a new video, then so many times I would just skip that channel. Okay. So this would be the information that we consider. Okay. And for the images, we actually do the thumbnail images. We don't analyze in our model the image duration. We use to append the text. So you keep the image and they give you possible text. Okay. So let me give you a very simple example. This again is this. Right. So in this image, what do you see? You see this possible, right? You see name. You see team. Okay. You see happy. They are very happy. You see excited. So the API just give you and look at this Coca-Cola, again in Spanish or in Italian. And you can see celebration, I think because of the color, okay. And you can see holiday because of the color again. You can see decorative, you can see snow. Okay, you can see because snow, you can see winter, right? Yeah. There's some happy stuff. Okay. And a lot of text actually can be correctly associated with image, so that we don't directly analyze images in our model. Instead, we convert images into a sequence of text. Okay. All right. So with this in mind, let me show you the models. Okay. And so for each of the video, they are actually becomes some actual token words like team, okay, like the BTS, like, and then we use the word-based deep learning methods to deal with the text to actually project each word into a dimension, okay, a space. Okay, so we actually represent each of the words in a 300 dimension space. Okay. So that two words, if they are highly related, their positions in the 300 dimension space will be closer. If they have been used in the similar context, they will be close. So that's a different method to work for the natural language models. Okay, so all the metadata they are converting into vectors. Okay, and then so we actually have this. So we have 300. If you have n tokens, that would be 300 times n tokens. Very long, very large space. And then we use the multi-tech extension. Have you heard of multi-tech extension? In trying to multi-tech extension, trying to learn even a sequence of words. What are their interactions? Right. Let me give you an example. I feel not happy today. Not do not multiply I. So they will not change the definition of I in this way. Not multiply. So the happy will be from one position move to another position closer to say, closer to frustration level. Okay. So the multi-head attention means you have a long sequence of words. Okay. Their interactions may not be the same. So we try to learn because of we have not given happy, so I'm not that well. Okay. And right. So not does not multiply. So I will not be complete. Still I'm not the same. Okay. So anyway, that's the natural language processing mechanism, or so we actually trying to learn their relationship, and then reduce their dimension into 300 dimensions, meaning that you have 300 variables in your model. And then through the fully connected, this will be the classical neural network models. And then we also consider some of the numeric data features that we already mentioned, that how long is the video, right? How many subscribers of your channel, how many video have this channel published. So these three variables or these three features are numeric. Okay, so they don't need to transform by the deep learning model. So we just concatenate 25, we actually reduce 25, and then concatenate 3 to become 28. And then we try to receive alpha, beta, P, and A0. So we actually build a classifier of 2 layers at the end of the test. Okay, so this will be the whole deep learning model dealing with the sequence of words to represent video title, video category, image, captions, and then do this. Okay. All right. So any questions? All right. So let me quickly go through the empirical evaluation. All right. And so we start to collect the data. Okay. So we write a crawler to crawl videos. Okay. Publish on YouTube. And we target at 12 industries. And there's no reason why this should show in. Okay, we airline, okay, beverage, Coca-Cola, Pepsi, camera, Nikon, like car, okay, fashion, LV, chocolate, cosmetic, food, perfume, sports, technology company like Google, Apple, they all have their official account on YouTube. Sports, others, all together, we actually monitor or collect data about 237 videos. Okay, 237 brands, and then we collect the video over almost over 3 months. So from 2002 February to 2022 February to 2022 May. Okay, and for each day we just using API to check whether there's a new video on the those brands that we monitor, and for those esteemed video, what would be the number of view count today? All right. Also, and for each of the video that we collect, we at least we need a 30 days view count so that we can use them to build models. We can use them to test our models. And so altogether, we collect 3,707 videos, meaning that our data set used for training and testing will be 3,700, a little bit more than 3,700. And then this will be the statistic, descriptive statistic, okay. And we evaluate our methods using MAE, mean absolute error, RMSE, rule mean square error, and MAPE, okay, over 30 days, right? Because we actually produce a curve, so we can calculate the errors of every day in the package. And we also measure the less than 30 days, what would be the error of the step. So we also measure the MAVR and of phase searching. All right, and we do the tenfold cross validation, and we have 3 benchmarks in this research. The first one is we use the training data to the curve fitting. So we have all the alpha data here. And for each of the brand, we take the average of the prediction mark. Okay. So for all the Coca-Cola, no matter how long is your video, you just use the average alpha data, average value of the parameters of the same brand to do the prediction. Okay. So this would be a very primitive benchmark. No learning at all. Do the curve fitting, use the mean value of the brand to do the prediction for any video associated with the pertaining to the brand. The second one will be a little bit more specific because every video you have category, right? So for Coca-Cola, you can have a category of sports. Coca-Cola also can have a category of, for example, concert. So you cannot use the concert to predict sports, even they belong to the same brand, right? So we do another more more fine-grained average. So we average over the same brand, same video category, have their average parameter values of the prediction model, and then to predict the other one. And then we also do another one is forget about the diffusion model. Use your metadata. The way we predict the phase search. Okay. we want to see whether the diffusion model will improve the diffusion result. Okay, so anyway, this would be the 3-1. We also design two performance upper bound. The first one would be, I just use the curve take the level. This will be the upper bound. Very ideal case, right? No one can take it because we already know all the potential values. And the second one would be do the curve fitting and use the curve fitting to do this, right? And because you already know the first 10 days of the values. So the result actually will be much better than you don't know any of the observation. Okay, so I reconsider these two will be the performance upper bound, right? Okay, and we want to see how much difference between our prediction to the performance upper bound. But anyway, so this is the results. Not very impressive. If you look at the MAPE, 200% percentage value. The meaning that if your view count is 100, our result would be 300. But if we compare the two straightforward average prediction, you look at this. How much we improve, right? And there's so far we cannot get close to the two upper bound because if you do the curve fitting and then the error will be like 7%, that's unacceptable because you know all the results, right? And if you know the 10 days, because the 10 days has set the constraint so that your curve will not vary too much from the. So anyway, 7% performance upper bound, 21%, we are like 10 times of their error. Not very good, but it actually can beat the other two. So that's the reason this paper has not been submitted because student has graduated. Okay. And I need to find someone to pick up and then improve this number so that, for example, if this can become like 90% or 100%, I think that would be publishable. Okay, so this is a message to all the graduate students. If you finish, your professor don't want to publish because the result actually is not publishable. Okay, you can publish the paper, this paper. I can publish this paper at very low, medium quality journal, but I don't want to waste my time to write medium quality paper. So I still need someone, my student, to help me to improve this. Okay, all right. But I think this would be a very good start of us working on this. Right, we can reach 200 and compared to the very naive benchmark. This would be considered a very good improvement. Okay, and then for the day 30, this is something I want to show you. For the day 30, again, don't look at it. Okay. And we do the curve fit, right? We build the model and then we only consider the day 30 results. Again, 200 MAP 200 over 200%. But if we do prediction without curve fit, we use the metadata. The way to predict the 30 days, right? Okay. We look at the results. So this actually echo to our research motivation. A lot of studies, remember the six, right? The right hand side, upper right hand side. A lot of study using the metadata directly predict the day 30, day 40 is not effective enough. At least using our data, the error, percentage error, is more than 20,000%. Okay, So underlying, if we are constrained or if we, it's a lot of more effective if you assume there's a diffusion model taken from the literature of marketing, and this prediction, popularity prediction, you can generate or produce a more effective model for the prediction. So this is actually a very good result or good feedback to us that our initial assumption is correct. Okay, we need an underlying model to guide the whole prediction process. All right, we also do some other we call ablation test, or we were trying to understand the impact of different categories. Okay, so if you look at these results, and this is we incorporate all the features. So you remember 279. If we remove the thumbnail, don't consider the images features, the result will be the worst. Meaning that these findings at least indicate people's viewing decisions are influenced to a certain degree by the image. If the image is not so appealing to you, then you don't want it. Okay, because if we remove those features, the result drops a lot, right? The error becomes a lot. And the second one will be the video type category. Okay, so this result actually suggests a lot of people, they use the query to query their future video. Okay, like because if we remove the video copy category information, the result becomes the second worst. Right, become the second worst. And what are the information that less important? The blue one. Okay, the numeric features. People don't care about how many videos that ran being published, because if we remove the numeric features, the result does not drop too much. Okay. So anyway, this is the message behind this. So anyway, the conclusion is we propose, at least to our knowledge, a novel diffusion model, popularity prediction model, and we using 3,700 video to do the training and testing, and we found that although I'm not satisfied with the result, but the result actually are appealing or promising, meaning that we beat the naive models, and we also beat the metadata, and without considering the diffusion model to predict the day 30. Okay. And the future, there are a lot of studies that they can consider exploring other available information to attract additional features to improve the performance of the prediction. And another one is more interesting. I would ask one of my students to study. We only consider one video to the prediction. But if videos are interconnected, meaning that some video for the same frame, your new video may affect the income of public. Some machines, like some basically penalize because I want this video and still say background. So what are the characteristics of the video that can create synergy effect? So that every video or many videos they can improve their income. What are the characteristics that may generate the cannibalization effect? If we can understand or build a model to say this is a cannibalization, this is a synergy, then we only push the video to the potential of synergy. Creating a synergy. So that would be the whole decision would not be based on a single video. Okay, they actually consider the combination effect of the video. So with this, I conclude my presentation, and I don't know whether you have any questions. So, oh, yes. Yeah, and I think I think it's a very good suggestion. Giving us direction for my next student to work on. Transfer learning is a very popular and also important with matrix data and also so I think this is a very good. Uh, 39, okay. Okay. 39.
Thank you for your excellent talk.
Thank you.
And I think that for the curve fitting problem, I think the uniqueness of the solution is not guaranteed. Actually, so
Yeah.
there are many optimal solutions to minimize the error. Error means that the full curve. Right? So I think that makes some your problem unstable to choose the parameter. There are many optimal solutions that result in same
Yeah. But I think it's a good application or comment. Actually, giving not a separation. We can actually use different code using therapy to generate different so that we can focus on and you can give them some of the so I think to answer your question, we don't know which code to use. So we know that it's code using consider with the minimum errors. So we give them the alpha beta and this will be the higher otherwise. So that we can actually focus. So before we do the transfer, right? So we can spend 3,000 to 12,000, and so that the market. By combining your two companies, then that will be a very good situation.
So because of time limit, so I want to ask one student.
Please.
There are the as a factor of
Yeah, I don't know about, actually, I think one of the undergraduate students after the YouTube. It seems to me, according to the YouTube demand from the he mentioned something about it. We were concerned about stuff because we don't know which family
But I do echo the importance of it because it makes things, it changes something, even the change the limit. The movie, then in Chinese, which is, you know, at least 3 days. And then the different area and different numbers. So a lot of times people like people feel young and older than you. I do get the next most cases that most of the people to go back to you know recognize that something that you are recognized that you know to get on it. That used to me. So that is the target for us. So that's why actually we take it out by access even if it's out there. At least they don't need that you should change the company. But even the things for the company, I don't know that will that at least that will hurt the foundation of our institution. Because we are based on one people come up with. Okay, so I'm sorry, but because of time, we have to make the seminar. So let's give our weekends again for the wonderful talk today. Thank you.